You want to see the wave?
Wavy?
That was big in the 80s.
I like that.
That's pretty good.
The wave.
We have a wave. Somebody named Wavy.
Okay, so what is a wave? Well, waves are caused by the wind blowing over the water. And the distance that the wind blows over the water is called the fetch. Can you say fetch? All at the same time?
Fetch. 1, 2, 3.
So if there's a long fetch, you'll have bigger waves than if there's a short fetch. Okay? The biggest waves come where wind has been blowing for a long time over the water. And what happens is, as the wave grows, it picks up more wind, because it's like a sail. The taller the wave, the more wind it catches, and the wind imparts energy onto the water, and that makes the wave even bigger. So it's what we call a positive feedback loop. Bigger wave catches more wind, and that makes it even bigger. Of course, it can only get so big because gravity pulls it down. But you can get some pretty big waves in places. Now, waves have different parts to them that you need to know, the parts of a wave. The crest is the top of the wave. The trough is the bottom of the wave. The wavelength is the distance between the wave crests or between two wave troughs. It's the same distance. The height of the wave is from crest to trough, or from trough to crest. It's not from the middle line up. It's from the bottom to the top. So if you hear a weather report that says 6-foot waves, 6-foot seas, that's what they're talking about. From the bottom to the top is 6 feet. So your boat will be going up and down 6 feet.
Swells? 6 feet.
6-foot swells. You need to understand the way the... oh wait, there's one thing I didn't talk about with waves is it's not written on here, but it's called the frequency. The frequency is how many waves pass per second. And if you're sitting there watching ocean waves, you're not going to get more than one wave per second. You're counting the number of crests that come by. Usually it's maybe 5 or 10 seconds between waves, right?
Yes.
So let's say it's 5 seconds between waves. Then your frequency is waves per second. 10 points. If you and your group can tell me what is the frequency of waves if they're coming by once every 5 seconds. 10 points. White is correct.
What'd you say?
What's the frequency of waves if the waves are coming by once every 5 seconds?
Yeah.
Peach is correct. Got to do a little math here. A little math in Marine Bayou. Mary Beck Shell Woman. Purple's correct. Orange is correct. Blue is incorrect.
Oh, George.
Anyone else?
Hang on.
Go back to the cheeky.
Here.
Why did you say it? Created to waste, right?
Green correct. So if it's one wave per 5 seconds, that's 1/5, which in science don't leave stuff in fractions. What's 1 divided by 5? You should know that in your head. 0.2. 0.2 waves per second.
George, what'd you do?
Wave per second, there's another name for wave per second. You know the scientific term for waves per second? Hertz. You ever heard of hertz?
Yeah.
What sound is?
Sound waves are measured in hertz. My voice right now is at about 1,000 waves per second. You can go higher or lower.
Okay.
That's about 1,200 right there. Let's look at how particles travel as a wave goes by. Here comes a wave, and there's a particle, and it does a little loop. As the wave passes, the particles themselves don't move along with the wave. A wave is energy being carried along the surface. But if you watched a water molecule, as the wave goes by, the water molecule just does a loop and ends up back in the same spot. So the water itself is not moving along that way. The water molecules just go up and down. Imagine you were on a float in the middle of the ocean and a big wave came by. You wouldn't move along like this with the wave unless you were surfing it, but that's a little bit different. That's only near the shore when the wave is breaking. If you're out in the middle of the ocean and the wave comes by, you'll be on the float and you'll kind of go up and down, and the wave will just go by. You don't go with the wave. So what's moving along in a wave is the energy. And the particles themselves just kind of go up and down in little loops. The deeper you get in the ocean, the less the influence of the wave. So you see the influence of the wave only goes down to a certain depth. I'm not sure what they're showing here in this picture. I think what they're showing this picture is if it were shallower. If it were shallower, it makes the wave where it doesn't go in circles, but it kind of flattens out the motion of the particle. Do y'all know what shape that is?
An oval.
An ellipse.
An ellipse. It flattens out the circles into ellipses if the water is more shallow, if it has a shallow bottom. Watch the particles here. This is a good simulation. So it does show a little bit of forward motion there with the particle.
Looks fun.
It's pretty cool, isn't it? Are they both circles on both sides?
No.
You can see down near the bottom there's very little wave influence though. More wave influence near the surface. Very neat. Hey, there's a big crashing wave. So why do waves crash?
Because they come too top heavy.
Why would they do that? Why not just not become top heavy?
Because they come off the
Because the bottom becomes more shallow. So, if we have the bottom of the ocean right here, and here's the surface with the waves. Aren't I good at drawing waves?
Yes. I see Coleman on the board.
Well, if the bottom of the ocean starts coming up like this, the wave's influence spreads a certain amount, to a certain depth, as we showed in that last video. Let me back this up. Kind of distracting, isn't it? So you can see the wave's influence goes to a certain depth. Now, let's say that this wave's influence is this deep. So right now it's just traveling along, but as it gets shallower, the wave's influence hits the bottom, and what that does is it pushes the entire wave upward a little bit. And so the wave's influence is, let's say, that far. It's going fine, it's staying at the same height, staying at the same height, staying at the same height, and now all of a sudden it's shallower, the wave's going to start being pushed up. And the wave will rise. So the wave starts growing as you get shallower. And like I said, gravity has an influence here. That wave can only get so big, and remember, it's traveling in this direction. And what basically happens is the bottom of the wave is being dragging on the bottom, and the top of the wave is just moving forward. So the wave starts to topple. The bottom of the wave is rubbing up against the surface of the bottom surface of the ocean. Those molecules can't go forward as fast as they were, as the molecules are turning over and over. They run into some resistance here. It's like the wave is moving along, and the bottom hits something, and the wave falls over. That's wave crashing. And if you ride it just right, you can get a surfboard right here. This is me surfing. And follow the crashing of the wave, and use gravity to kind of go down the slope as that thing moves in. Yeah.
I was wondering, like a lot of waves, in some areas waves get like real big. So like, what factors like what makes it different? Like, is it like incline?
Yeah, it's the incline. So we have lame waves around here because we have a very shallow incline, and the waves have a long time to lose all their energy. So our waves start losing energy way offshore. And by the time they get to us, a lot of the energy of the wave has been diminished by this gradually rising slope. But if you go in the right places, like we're talking about Mexico or Hawaii or something, it'll be real steep on the bottom. It'll be deep, 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 and then steep. And so the wave hasn't lost any of its power, and then all of a sudden this climbs, this pushes it way up, and it goes just from nothing. It looks like this. It'll look like this. You see what I'm saying? It'll just be the normal size, and then all of a sudden it just runs into this wall and just gets thrown upward. The whole wave gets pushed upward, and you got this giant wave that kind of comes out of nowhere, and that's because it's so steep. So that's where the best surfing is, where it's deep, and then it comes up steep all of a sudden. Sometimes this happens out kind of in the middle of the ocean in places, where there's an undersea, like a seamount, that doesn't quite break the surface, or Gaia, and you'll just be out in the middle of the ocean, and it'll just look flat, and then there's this area where there's these huge waves. People go out in boats to surf those things, and they're just out in the middle of the ocean. Did you see Point Break, the movie? You ever doing that Point Break?
In Mexico, and people, somehow, I guess it was like really steep because like, I couldn't even surf there because the waves just came up and they like actually come all the way out on the beach and just smack on the grass and then come all the way back. Like people couldn't, if you went out there,
yeah,
you'd get dragged out. Like you couldn't swim there.
Too dangerous.
The waves were just like huge right by the beach.
Yeah, it's pretty amazing some waves that are produced. I think I have a good video footage of a giant wave. Let's talk about storm surge. You ever heard of that?
Surge.
So here is sea level, and where we live, this is very applicable to us. So we live here. Here's my house, and normally the sea level's way down here, and everything's fine. And then the tides come in. You know about the tides. So you got high tide and then low tide. And they go back and forth around what's mean sea level. Mean means average. So this is the average sea level. The average sea level is the average between high tide and low tide, somewhere in the middle. So high tide comes in, low tide, and that's normal. Well, when a storm comes from offshore, it's got high winds that really push a lot of water. And so what you'll get is a bunch of water coming into shore. Now that water, if you were to take a squeegee, y'all ever used a squeegee before?
Squeegee. Yeah.
And if you squeegee the water, you'll see as you're pushing, the water builds up in front of the squeegee. You got more water right in front of your squeegee than you do everywhere else, right? Mm-hmm. That's like the storm surge. And now imagine you push that water into a wall. That's like all that water coming up here and hitting the wall. You're going to get a big pile of water there. And so storm surges can go up well above normal high tide. It can go up 15, 17, 20 feet of storm surge. And so what's normal high tide here, the surge can come in and flood areas. They're always worried about storm surge in front of hurricanes. That's what happened in New Orleans. They got a big storm surge. It came right at high tide. That was bad luck. This big hurricane blowing a lot of wind and very large amount of water. And it just, New Orleans sits below sea level. And they have barriers, but the water was higher than the barriers. And just went right over it. And then washed in and flooded the whole city. So you don't want to live at a place below sea level like New Orleans. You're in danger of that. You really don't want to live where you're only 2 or 3 feet above sea level, which is where we are on this island. You can get a bad storm surge and it can cause a lot of problems. We're in an especially bad location for storm surge. Let me show you why. If you look at a map, tell you what, let me get it on the screen here. Get it on the screen. Let's look at a coastal Georgia map. Map of coastal Georgia.
There we are. CCGA, baby. Oh my God.
I need it to zoom out. Okay, they should. Here we go. All right, check this out. Whoops. So here we are. Fort Frederica. This isn't Fort Frederica. This is School Frederica.
Yeah.
Frederica, what?
Okay. We're trying.
So let me show you about our particular location. This right here, you can see this big curve right here. That's called the South
Belly.
The South Atlantic Bight. And it looks like it's just a big monster took a big bite out of the coast, right? That's why they call it that. And what happens is the water, if you got a big storm that's coming right in this way, water will pile up right in our area because we're at the middle of this curve. It'd be kind of like if I was squeegeeing water into a corner. If I squeegeed water into the corner of this room, some water would hit there and go that way, and some water would hit there and go that way, and all the water would pile up right in the corner. The corner would be the highest amount of water, right? Well, we're right in the corner. So we get the highest amount of water, and it happens every time the tide comes in. Every time the tide comes in, we get higher tides than everybody else does. The tidal difference here can be like 10 feet from low to high tide. You go to Miami, it's like 3 feet. Why is it so much here? Because we're right in the middle of the fight. We're right in the middle, and the tides come in, the water hits there and goes down this way. The water hits here and goes up this way, and it all piles up right where we are. So we got the highest tidal difference, and we got the strongest currents. Remember the current that was flowing when we went out there the other day? You don't see that around Hawaii or Miami or any place like that that's not in a location like we are, where the tide really comes in real hard, and then when the tide goes out, it really goes out real hard. That's why people get dragged off by the currents around here. Yeah.
Doesn't it depend on how far you are from the equator? Because I would said down in Key West there are no tides. Like the tidal difference is like maybe a foot.
I don't know if that has to do with some particular geological arrangement with Key West, but in most places that aren't in an area like we are, that's just connected to the open ocean, it's usually like 2 feet. So I don't know if it was.
So is Maine something like that?
I don't know if it was. Yeah, Maine would be like that too because it's not on a curve. So I don't know why Key West would be less than that. But most places that are just touching the open ocean are like 2 feet. Yeah, 2 or 3 feet.
Didn't you say that last year that the ocean used to be like where the connected swamp was?
Not last. Yeah, yeah, a long time ago. Yeah, millions of years ago.
And that's why it's counted up. Is that the reason like it looks like a big cut's been taken out? Because the coast used to be there, and it's just kind of like the cut's like going away.
No, well, the way our coast is like that. If you could just imagine that whole curve right there just moved inward. It used to go like this, and it's just moved outward over time. Every time an ice age happens, the water goes out, and then the water comes back and pushes up after the ice age. The water comes back and pushes up a bunch of sand. So the coast used to be where Waycross is, and then a bunch of sand got pushed up and formed a row of barrier islands in front of Waycross. And those barrier islands were big piles of sand, and that has trapped water behind it, which is the Okefenokee Swamp. And that has just gradually moved out with each ice age. And if the polar caps completely melt once again, and the water goes way back up after the polar caps melt, the coast will be there again in Waycross. And we'll be 80 miles out in the ocean. And the school will not be here. People at Waycross High School, they'll be on the ocean. And they'll be like, this is sweet. Yay, global warming.
The government.
Isn't that interesting stuff? So we're at a particularly bad place if we ever did get a hurricane hit here and had a lot of storm surge. However, we're in a lucky place because, one other thing, we're in a lucky place because hurricanes usually come from the equator and come up like this, and they'll usually follow the Gulf Stream up, and they'll miss us because we're so far inside on this curve.
Oh.
So the hurricanes will usually go like that and miss us, or they'll take a turn down here and miss us and go through the Gulf. The Gulf Coast gets hit a lot with hurricanes. And we haven't been hit by a major hurricane since 1964. Hurricane Dora came right through here.
Dora the Explorer.
Dora the Explorer. She came right through here and she took a big hunk out of the island. There used to be houses and such at the, y'all know where the lighthouse is, right?
Yeah.
And y'all know if you going away from the pier, if you go from the lighthouse, there's a beach right there. Y'all know that beach? There used to be houses right there. And the Hurricane Dora came in and it just took a whole chunk of St. Simon's and all the houses with it. And now there's that beach there. Yeah, there's rocks. They put up rocks to try and keep it from happening again. There used to be houses. There were 2 blocks of houses that are now in the ocean. That, well, they're gone. They cleaned them up. You can find old pictures of when that thing happened. And that was a small hurricane. That wasn't like a Category 5. It was like Category 1 or 2. So if we ever did take a direct hit from a big hurricane and it happened during high tide and there was a lot of storm surge, we'd get flooded pretty bad. It would be pretty bad. So let's hope that doesn't happen. Video footage?
Yes.
SpongeBob. Are you getting this?
Yeah, it's hard to like.
It doesn't look like it's over. You ever heard of a rogue wave?
Yep.
Okay, rogue waves are really giant waves. I don't think you can see the screen. You gotta loosen it. Look.
Oh, gee, thank you.
Loosen it. And aim at the screen. Okay. See what I'm saying?
Yes.
Rogue waves are real big, giant waves. And this is the first reading, the first scientific evidence ever of an actual rogue wave. Sailors used to talk about these things all the time. That they'd be going out in their boat, just floating along. Are y'all with me? Some of y'all don't seem like you're paying much attention here. Boat going along, and all of a sudden there'll be this huge wave come up. Way bigger than normal waves. And they called them rogue waves. And everybody thought, these guys are just making this up. Or they never had any evidence of it. But finally, in 1995, they were taking readings in Norway with a instrument that measured the wave height, and waves are coming along like normal, and then bam, a rogue wave is like 3 times as big as the normal wave. And it was so big that it damaged the machine that was doing the readings a little bit, but it was still able to do its readings. But it got the reading of this rogue wave. That was the first evidence of one, and I think it's called the Dropner wave. And a rogue wave can be way bigger than a regular wave, and more powerful. And the reason why they happen, scientists figured out, was because of what's called constructive interference. Have you ever heard of that?
No.
That's when 2 waves are coming along like this. Are you getting this? Get this on camera. 2 waves are coming along like this, and when 2 waves hit one another, if their crests hit each other at the same time, you add together the wave heights to make a new wave. And we call that constructive interference. If you learn about how waves work, if this wave's going along and another wave's coming along and hits it, so here this wave is coming along, a different wave, and if their crests coincide with one another, then the actual wave is the combination of the height of the 2 waves, which will now be a wave that's twice as high. And you can have this effect multiply if there's many waves coming from different directions and they all just coincide at the same time. You can get a one single wave that's really, really big and way bigger than all the others, and they call that a rogue wave. And these have been known to sink ships. And they think several of the ships that just go down and disappear may be because of rogue waves. Come and just flip the ship over. Here's video footage of a rogue wave.
Okay.
Oh no, this is the biggest wave ever surfed.
It just keeps going up.
So who's that? Still the word. I'm starting to rethink this idea.
Like a tidal wave. Oh my god.
Where is this?
It's like
I think it's Australia.
What is so switching? You see a shark.
How much
Go bail. Go live. He's an animal.
He's like shot.
Chicken Joe.
Take it.
Did he go down?
Did he wipe out?
That would hurt to
Oh, he wiped out. No.
Hank Daddy's
Looks like he did.
He's gone.
Yeah. He got it.
It's lost in like the
There's a shark in that guy's cell.
I thought I had another roadway
Did you?
on there.
And the one.
Hold on, I think I have another roadway video.
You surfed it, like, he broke it out of the top.
Oh, man.
Oh yeah. It's cold in your chicken Jeff. Your chicken Jeff. Chicken Jeff.
Chicken Jeff? Why am I Chicken Jeff?
Here it is.
Does it crash?
Alright, can you do that again?
Say that again.
Pretty much okay.
Imagine having to hold down. Like, yawn on top. Like, oh,
Took the nose on top. Oh, dude.
If your ship's big enough, you can handle it. But a small ship, that might have knocked it over.
Mermaids are real.
I believe it.
Cool.
Just because Tony said that.
Okay. Bigfoot's real.
Roadways.
I don't know if that's like
Why the outside down?
I got Where'd they go, Oh God.
They died. Oh, he's got a waterproof camera. Yeah, that nice proof before he was
All right.
live on Facebook.
Read about waves.